the real world, and mean value theorem is what they used for that. It was a lawsuit, and so it went on for a long time, but they had to use calculus to settle the dispute. It was about speeding, and we'll talk about that. But all the mean value theorem says, and it's not hard, but you have to know the conditions. You have to know the theorem, and we abbreviate this by saying MVT. Thought I was. I know it should be red, but maybe when I do that, that goes away. I think that's it. Okay, so first thing, I have to match the conditions. I have to have a differentiable function. What does that mean? Okay, it has to be continuous, and it has to be able to find the derivative. F prime of x has to exist. And actually, this is wrong. It should be on the open interval. The derivative has to exist on the open interval, but when you apply the mean value theorem, the interval must be closed. But I don't care if the derivative doesn't exist at the endpoints. I didn't type that up very well. So it has to be differentiable in the interior, and it has to be a closed interval. And all it's saying, and I don't remember it by all those symbols, it's just saying that if I find the slope between my endpoints here, so if I take this, I would have that nice red dotted line, which I'm going to draw on again. Do you remember what that's called? If you take the slope at the endpoints? It's the secant line. And it's also called an average rate of change, right? Remember that? I know Haley does, because she was making up her test and she had to do it and she remembered it. So I was very impressed. Okay. All it says is that if I can draw that secant line, and don't you think this is true? Somewhere on this interval, my tangent line will be parallel. That's all it's saying. This is the slope of the tangent line. This is going to come in and haunt us in second semester because we're going to see a different way of looking at this. Right now, it shouldn't be too bad. So if you take this equation here and you multiply both sides by b minus a, and this by b minus a, it's just a different form, you get this. And we're going to be doing the fundamental theorem of calculus next semester, and I need that statement right here to prove it. Now, I haven't proved it this classes for a while, because usually nobody wants to. No one cares. But I might do it as a video and put it up online. If you're interested, you can see the proof. But I have to use the mean value theorem. It will occur on your test. So what it's saying, what if I have, this is my position, and this is my time, and I'm driving to Chicago. Actually, I'm going across Indiana on the toll roads. Anyway, so we do this. We slow down, speed up, might stop for a while, etc. And what it's saying is, someplace, if I draw the secant line, I think I'm going to get a little aid here. Ooh. If I draw the secant line through here, there has to be at least one place where the tangent line will be parallel. So if I do it here, it might be too thick. You see that? Oops. Oh, that's a little crooked, isn't it? Are there more? Yeah, there's more. Yeah. Okay, if that's my position, do you remember what this secant line was called? That was my average velocity. And remember what the tangent lines are called? That's your instantaneous velocity. They're coming back. Remember that the slope of the secant is your average speed, where the tangent line is your instantaneous speed, right? So let's say you average 75 miles per hour. You average it. That means that someplace on your speedometer, at least one time, it had to read 75 miles per hour. And if the speed limit is 70, what does that tell you? You've been speeding. That's how they do that. That's how they did that in that court case. They were accusing him of speeding. And I haven't read the whole thing. This went on for months, but they used the calculus. So when you go into Indiana, you have a certain distance, and they can calculate your average speed. Because on the ticket, when you get the ticket, you have mile markers. So they know the total distance you traveled, and they also clock you in on the time. So they notice the time you took. So let's say you're in a hurry, and you don't want to stop. You got a full tank of gas, you're just not going to stop. And you go through there, and let's see, I'm trying to think what the speed limit is out there. Probably 60 or 65. It's not as fast as it is out west. And let's say it's 65. Your distance divided by your time is 65 miles per hour. Then that means your speedometer had to have said 65 miles per hour. And if the speed limit is 60, they can ticket you. And that's how it was done in the court case. Yeah, well, it's true. So if your parents knew calculus and you say, oh yeah, I was only going this fast, if they knew some calculus, they could prove that maybe you were speeding because they knew how long it took you to get someplace. Yeah. So not to worry. Okay. Geometrically here. The main reason we have to do the theorem, two reasons. If it's a fundamental theorem of calculus, that means it better be pretty important, right? Okay. So I need this to prove that theorem, even though we may not prove it in this class. The second reason is it's going to be on the AP exam. It's almost always in the free response, just like the max-min existence theorem. So we have to know the theorem, and it's not that bad. All it's saying, and I'm sorry it's so light, it's very hard to read, the slope of the tangent line has to equal the slope of the secant line. That's all I have to remember. The function has to be differentiable on AB. I'm on a different sheet. Sorry. Then the mean value theorem does not apply. The function's got to be continuous on that closed interval. Okay, notice what I wrote here. This is correct now. It's differentiable in the interior. That's right, interior. And it has to be continuous on the closed interval. Those are the conditions. So if it's not differentiable in the interior, you can't apply the mean value theorem. What would be a situation where it's not differentiable? What's not differentiable mean? You can't take the derivative, so it's not continuous here. Okay, so if I went from this point to this point, and I drew that secant line here, there is no place that will be parallel to that because it doesn't apply because you have a big discontinuity here. It has to be a closed interval. It has to be a nicely behaving function. It's got to be continuous. I can't do it. This is the secant, not the tangent. I don't know. Can I find a place on here where it's going to be parallel? I can't. I don't see how I can do it. Yeah, you can do that. But and even though you may have a function where it's not differentiable, maybe it's not even continuous, that doesn't mean that the slope of the tangent line can't be equal to the slope of the secant. It's just not a guarantee. This is another one of those guarantees. So that's all. There's some problems. So the first part of the assignment is just do the mean value theorem. And then on Monday, we'll talk about what a derivative tells us about a function. Well, I'd like to graph that. Do you know what it looks like? Say yes. Do we know what it looks like? It's x plus 1 cubed. Well, what does x cubed look like? Yeah. It looks kind of like this. And this plus 1 shifts it to the left 1. It's just kind of nice to see these. So when you do the max mins, you might want to graph them just so you can visualize what's going on. And so it's -1, which happens to be this point, and 1. And I'm going to draw this secant line. Oh, by the way, is that a closed interval? Yes. Is this continuous and differentiable? No problems. So we can do the mean value theorem. So we're going to write it down, which says the slope between here and here. This is -1, and where is the y value? X is -1, what's y? 0. So I'm going to do f of b. So all I have to do is do regular old slope. It's the average value rate of change of the function. I said it wrong. Has to equal f prime of c. Well, let's see, what's this one? This is at 1. When x is 1, what's the y value? 8. Because, well, it's not 8, it's g. I mean, it's not f, it's g. G of 1 is equal to 1 plus 1 cubed. So let's find the slope of the secant line. So let's see. That's f of b, so that's 8 minus this y value is 0 over 1 minus a minus 1. That has to equal my derivative. What's my derivative? Now, you can put c in for x, or I don't care. Or we can just leave it as x. That's just slope. So you're just finding the slope here between these two endpoints, and it has to be someplace in between where the slope of the tangent line equals the slope of the secant line. They're parallel. So what's the derivative of that function? Well, that's true, but what's this derivative? 3 x plus 1 to the what? Second, times the derivative of the inside. No, it's this 1. Okay, let's find x. So this is 8 over 2. Let's find out where that is. I'm going to show you a little trick here. Are you ready? I don't want to square that out. I don't have to. What I'm going to do is isolate the squared term. I'm going to divide by 3. So I'm going to get 4/3 is equal to x plus 1 squared. We don't have to, because you know what? What can you do to both sides? What do you think? You can square root it. I thought you said square it out. Oh. You can leave it the square root of 4/3. You can make it 2 over the square root of 3. It makes no difference to me. I'm going to just leave it the square root of 4/3 right now. Well, yes, you do, because it's x plus 1, but we're going to see something here. So that whatever you put in here, x plus 1 has to equal the square root of 4/3, or x plus 1 has to equal, oops, that's the 1. Is x plus 1 equal to that? Negative square root of 4/3. But that gives me 2 answers. Let's look at our picture. How many answers are there? I'm on the interval from -1 to 1. There is another place. It's over here, but it's not in my interval. You have to check your answers. So I really don't need the -1. I just need the positive one. So if I solve that, I'm going to get what? I hate that when it does that. I don't know why it does that. So I'm going to get x equals the square root of 4/3 minus 1. Anybody know what that is? Look at a calculator. See, I can't get to the bottom of the screen. Damn. Now it works. Okay, so it's 2 over square root of 3. That doesn't help me at all. Square root of 4/3 is a little more than 1, isn't it? Or if you square root a little more than 1, it'll still be bigger than 1, huh? Yeah. It's what? And that's a negative number, but that's not in my interval. Well, let's do this one. Let's check it for sure. X equals -1 minus the square root of 4/3. Sam, what's that one? You have to do what? No. What was it? But sometimes you don't know. I mean, because I had a picture. Negative 2.154 is not in my interval, so we will throw that one out. So it's not particularly difficult. I don't think you should have a lot of difficulty with it. You've got some piecewise functions that might bother you, but that's the way it is. You ready to try the next one? Some of these are easier than others. Well, sometimes it helps to look at the picture. I have a closed, that's at 0.153. Okay, so I want to find the value on this one, such that I want to find the point on this where this tangent line is parallel to that. Now, we're going to look at this interval 0 to 4, and 1 over x minus 3. Do you remember what that one looks like? Well, here's 1 over x. What's the minus 3 going to do? Now it's going to move it to the right. So it's this shift. So I had an asymptote at 0. Now my asymptote is at 3. Are you okay with that? 1 over 3 minus 3 is 0. Doesn't mean that it can apply, because that's the first thing. No, why not? Does not apply. You can do DNA. Does not apply because the function is not differentiable at 3. It's not continuous at 3. Nope. I like those. But you have to be aware of the conditions for the mean value theorem. Because you know what they could do on the exam. They could give you a plausible answer, and one of the last choice will be, well, you can't do it or whatever, it does not apply. But you're going to look at it and just go through the process instead of saying, hey, wait a minute, it doesn't work from the very beginning. Does not apply. Let me write it. Yeah. Well, you'll remember it now from biology, right? I think we only have one more problem, right? Let's try the next one. Oh, there might be 2. Okay. What does that one look like? Well, no, it does look like a square root, but can you have negatives? It's a cube root. Yes, you can. So this one's centered at the origin. So here would be the right side, and then here would be the left side. Now, just from what we know about the cube roots in the origin, what's with the tangent line at the origin? It's vertical. Very good. Does a derivative exist when you have a vertical tangent? No. So this is not differentiable on the interior. But sometimes you may not see that. So how do you know it's not differentiable? What does the algebra look like? Yeah. This vertical tangent is a vertical tangent, which means it's not differentiable there.
What about the
In between negative 3 and 3. So here's 3, there's negative 3. And if you think about it, can you find, you might be able to find a tangent, but we don't have to do it because it says use the mean value theorem. I know it doesn't say that on your sheet, but it does. Vertical tangent implies not differentiable. I apologize for not having directions on there. You're going to have a problem if you try to use the mean value theorem as well, because what's the derivative of this thing? If f of x is equal to x to the 1/3, right? Why is it not differentiable at the origin? Why is it a vertical tangent? What's the derivative? 1/3 x to the what? 2/3. Okay, what does that mean? I don't know how comfortable you are with these exponents. What's the negative mean? It's in the denominator. So it's positive 2/3. I don't like fractional exponents. I don't have a feel for what they look like. So this is the cube root from that 3 of x squared. So this is what f prime of x is. A lot easier for me to think about this one. What happens at 0? Yeah, f prime of 0 is 1 over 0. What does that mean? Remember what happened? We had 1 over 0? It was undefined. So the slope doesn't exist. If it doesn't, it's most likely going to apply on the exam. Most likely. It could be a multiple choice question, though. A simple one. They will embed it into word problems, and you're going to go, oh, mean value theorem. And I'll help you find those problems.
It's a multiple choice test. That's just like, you don't get credit for work.
You don't get credit for work. So if you take your multiple choice test that you took on chapter 3, count up how many we got right or wrong. That's how you have to gauge it by. I might get Wells one of these days. Okay, this is the last one. It's the same function, but guess what interval we're on? Yeah, we're just doing 0 to 1. So it's just this. I chose this problem because you're going to say, well, it's not differentiable at 0, but I don't care. Okay, Sam, Mike? It isn't differentiable at 0. Well, it has to just be differentiable on the inside, not at the endpoints. You are right. The derivative does not exist there. And so I'll just quickly draw my little secant line. There it is. And there is a place here. Where is that? I like to call it X. I don't like C particularly. This is the curve. This is the black curve is the curve. That's the cube root. And that's y equals the cube root of x. This is the secant line, and this is the tangent line. So it does apply in this case. So it's f of b minus f of a. It's just the slope between the endpoints at 0 and 1. And then it's the derivative, which we did. It's just the slope formula. Mm-hmm. At the end point, it's okay. The theorem does not apply if the function is not differentiable on the interior. If you look at the equation here, we could go back and look at the equation from the other one. It doesn't work because you're gonna have to be cross multiplying with zeros and stuff. But this one's going to be better than that. What's f of b? That's the cube root of 1 minus the cube root of 0. This was easy algebraically, though. It's probably not that easy in the textbook. You know how that is. And what's the derivative? Can we just take what I did on the last slide? I know why. Do I have to go through it again? I can. Are you okay with just taking that? That's the derivative.
What?
Okay, let's do it again. Let's take the derivative of this. What's the derivative of x to the 1/3 power? It's 1/3 x to the negative 2/3. I just did that in the last problem. This is f of this endpoint, and that's f of this endpoint.
So where's the
Because it's a cube root. That's my function. The slope formula for this function is the change in y over the change in x. It's just do slope. What's the slope there? I have to know the ordered pair. When x is 0, y is 0. I know that. Look at the picture. When x is 1, what's y? When x is 1, what's y? What's the cube root of 1? 1. Okay, so what's the left side give me? This is what? 1 over 1. So it's just 1 equals 1/3 x to the negative 2/3. I don't know about you, but I don't like working with that negative exponent. No, so we're going to change it. Can we go right to what it is? It's 1 over 3. It's going to go in the denominator. It's the cube root of x squared. And that's a proportion. I love proportions, because what do you do with them? Cross multiply. You have to think a little bit. So this is going to stretch your algebra skills a little. So it's 3 times the cube root of x squared equals 1. And then I want to isolate. I always want to get x by itself, so I want to get rid of the 3. So I'm going to divide by 3. So that the cube root of x squared, and we'll take it one step at a time. How do I get rid of the cube root? Prove it. Some of you can say, oh, I could just do this fractional exponent. You're right, you can, but I'm not going to do that. I'm going to do it one step at a time. So this is cubed. What's 1/3 cubed? 3 times 3 times 3. 127. What's left over here? X squared. Okay, now what do we do? Square root. Now, I do get an absolute value there. It is the absolute value of x, and I don't care if you simplify the square root of 127. That's irrelevant to me. It's a pretty small number. You can just leave it. If you go to decimals, you got to have 3. Well, why waste your time getting out your calculator? Unless you want to know how big it is. I'm not going to keep the negative one. Why? It's not in the interval, is it? It only went between 0 and 1. So we're going to throw that one out. And there's your answer. It's pretty small. No, it's usually just the x. I'd have to look in the book and see. But I'm pretty sure it's just the x coordinate. But you could, and I would just use a calculator then. Sorry. So that's all the first part of the assignment is. The reading is kind of tough. I will ask you one more question, though. It says, state whether or not the theorem applies. That's what A is. And then it says, find the value of x on that interval that makes this equation true. I'm just going to ask one more thing because it may occur on the exam. What if you have this situation? Let's use the mean value theorem. Here is A, f of A. Here is B, f of B. And I'm going to tell you that f of A is equal to f of B. What's true about my tangent line? It's horizontal because by the mean value theorem, you do f of B minus f of A, but they're equal. A and B aren't. That is, it has to equal f prime of C. So that's 0 is equal to f prime of C. So we have a horizontal tangent. It's a special case of the mean value theorem. And when Faye knows the name of it, it's Rolle's theorem.
Oh, that was the name.
Yeah, it's Rolle's theorem. I figured might as well talk about it. You may run into it. They may not call it Rolle's theorem, but you may run into it. You have to tell me. But it's just a special case. You would get the picture and you draw the picture and say, well, f of b equals f of a, so the slope has to be 0. And you may not be thinking of Rolle's theorem. You're just basically coming up with it on your own when you do that. Because these two y values are the same. So this has to be horizontal. My picture's left. And that's all I think I have to say about that. I don't think we're done, right?
Yeah, please say it, but you still get it right. If you like the value, you don't have to say this one.
You don't have to say Rolle's, no. You have, I don't know, 6, 7 theorems that you have to know. Max-min existence, mean value theorem, intermediate value theorem. Sounds like mean value, but it's not. Fundamental theorem of calculus. There may not be any more than that.
You have to name them.
You have to be able to use them, and sometimes you have to name them. So if you don't name it, then you have to write out what they call the hypothesis, what the theorem says. Yeah, so you're better off if you just say mean value theorem. Otherwise, you have to say, well, the function's differentiable, it's on a closed interval, so I know this is true. You can do it that way and not know the names. But you better know the name of the fundamental theorem of calculus because it's fundamental. You know what the fundamental theorem of arithmetic is? I don't know. It may be. I haven't been in college math for a long time, but the fundamental theorem of arithmetic is that every number has a unique. What does unique mean? Yeah, one of a kind is special. Prime factorization. And you probably forgot what that meant. Anybody remember what you guys used to call prime factorization? Yeah, factor tree. So if I take 12 and I go to all the prime factors. It's 2 times 2 times 3. There's only one. I can't find another factorization for 12. That's it. That's the fundamental theorem of arithmetic. The fundamental theorem of algebra, nobody told you these things? Algebra is arithmetic with letters. So if I have f of x is equal to x to the n, we have at most n, you guys know what a root is? It's a 0 root. So if you have y equals x squared, I can have at most 2 zeros. Can't have 3. Now, that doesn't mean you will have all 2. Yeah. They may not have called it the fundamental theorem of algebra. We'll get there. It's so cool, though. But it'll take some time to get there. It's a toughie, but it's really important. Actually, there's 2 fundamental theorems of calculus. Okay. Work time, and I'll come around and answer individual questions. Does that work? Yeah. That would be perfect.